is Mrs. Taylor, and I am going to explain this free response question regarding continuity on the graph. We went over this in class, and then I told you I would elaborate more in video. So here it is. 1a asks, is f of g of x continuous at x equals 0? Explain why or why not. So the key here is that in order to explain if something is true, the why part, you have to use a formal definition, a theorem, a property. You have to state something that's been proven true in order to support your argument that something exists or is continuous or differentiable or whatever it is. So in this case, we're trying to support continuity. And so the requirements for continuity are if the function actually exists, if it has a value, a y value at that c value, if the limit is x approaches c of the function exists, and if the defined value is equal to the limit. So basically what this is saying is it has to have an assigned y value here. It's got to actually approach that y value from the left and right. And that's this conclusion here, is that not only does it have an assigned y value, but it approaches that y value on the left and right. So this is going to be our setup for proving continuity. So if we look at A, it says is f of g of x continuous at x equals 0? Explain why or why not. So at x equals 0, that looks like this. If we are trying to first test for our first requirement that it actually exists, we would say f of g of 0. And first I'll go evaluate my inner function g of 0, that's this graph here. And g of 0, well, where x is 0, g is assigned the value of 1. So I have g of 0, which is 1, but I still have to evaluate the function f at that value. So f of 1 over here, if I go to x is 1, it's negative 1, so that equals negative 1. So now I have the first requirement fulfilled for continuity. It has an assigned y value. So now let's test the second, which is the limit, as x approaches the c value, which is 0 here, of f of x, which in this case will be f of g of x, exists. So in order for that to happen, we have to verify that the limit approaches the same y value from the left and from the right in order for the limit itself to exist. Because if we just plug 0 in here, we've done the exact same thing we did up here, which is finding the defined value for the function, not testing for the limit. So it's better to test the left and right hand limit, see if they equal the same value. If they do, you know your limit exists. So let's see, the limit as x approaches 0 from the right, and the limit as x approaches 0 from the left. So just to clarify, if we just evaluated f of g of x at 0, that would be what we did in this step here. Okay, we're not evaluating the function. We're trying to find the limit. So that's how you distinguish between these two actions. Is here, we're testing for the existence of the limit, and the best way to do that is to see if the right hand and left hand limit equals the same value. So, as x approaches 0 from the right, g of x approaches, and here is g of x, and from the right it's approaching 2. Alright, so in that case, it would be the limit as x approaches 0 from the right of f of x. We would modify it so that it's x approaches 2. So one more time. G of x from the right of 0 is approaching the y value of 2. So the way I would switch this up is I would say the limit as x approaches 2 from the right of f of x. See how that worked out? We evaluated the inner first, the function first, and now we're moving to the outer at the value that the inner took. So 2 from the right of f of x, if I go over here, from the right it's approaching -1. Okay? So same process, but from the left. The inner function g of x is approaching 0 from the left at y equals 1. So I would modify my limit to be as x approaches 1 from the left of f of x, and 1 from the left of f of x, which is over here, would be -1. So the overall limit, it's approaching the same value from the left and from the right. That would be -1. Okay? So what we see here is that the function is defined. It exists. F of 0 equals -1. The limit exists. It has a defined value. It also equals -1. So I would say, in my conclusion for A, and all of this work has to be included as part of your answer, but my final statement would be f of g of x is continuous because f of g of x, well, instead of writing it out that way, let's say f of g of 0 equals the limit as x approaches 0 of f of g of x. So, is it continuous? Yes. Explain why. Because f of g of 0 equals the limit as x approaches 0 of f of g of x. And this work here would be what was necessary to support my answer. So you would repeat this same process with B, and what you would find is that the limits, the left and right hand limit, approaches 2 different values, and that would be why g of f of x is not continuous. So try that out, see what you get, and if you have questions, you can always come ask.